So the fundamental theorem of algebra was described in the video we just watched. Did you get the basic gist of it?
No.
Okay, the basic gist is whatever your largest exponent is, that's how many answers you should have. So if your largest exponent is a 4, you should have 4 answers. If your largest exponent is a 3, you should have 3 answers. Now, he was talking about the complex roots. Let's say you get 2i as an answer. If you have 2i as an answer, you should also have negative 2i as an answer. They come in pairs. He said they come in conjugates, which means one's positive, one's negative. So anytime you get an I or an imaginary answer, you should have either 2 imaginary answers or 4 imaginary answers or 6 imaginary answers. They come in pairs. Okay? Sometimes you'll have 4 real answers, 2 real answers. It doesn't really matter. There's not really a limitation on the number of real roots, but whenever you have imaginary, they'll come in pairs of 2, and you should have as many answers as your largest exponent. That is the fundamental theorem of algebra. Any questions on that? All right, so jumping right into examples, I told you guys that I was going to let him kind of do the teaching today, and we'll just do examples together. So here's example 1. The directions say find the number of zeros of the polynomial function. Remember, zeros or roots or solutions, those all mean the same thing. How many answers should you have to this problem when you're done? 4. That's the fundamental theorem of algebra. It's a big fancy name for a very simple concept. Have you guys picked up on that pattern before today? It's kind of probably something you noticed. All right. How many zeros should I have for this one? 3. The largest exponent is a 3. You should have 3 answers. Pretty simple. A little bit. Good. 3. Four. So make sure you're paying attention to the directions. If it just says the number of zeros, that's all you have to do. If it says find the zeros, then you actually have to come up with 4 zeros or 3 zeros or 2 zeros or whatever your degree is. That's how many zeros you need to find. That's what we're going to spend the rest of the class doing. Any questions? So basically what we're doing today when it says find all the zeros is exactly what we did yesterday. The only difference is now I want you to keep in mind the fundamental theorem of algebra. If you're not getting 4 solutions, you're not done with the problem. Okay? Do you guys remember how we started this yesterday? Had something to do with this number and this number? What? Yeah. You think of all the possible zeros there could be. That's kind of what we did in our warm-up today. That's exactly what we did in our warm-up today. So you want to list the factors of your constant over the factors of your lead coefficient. Our constant here is 2. What are the factors of 2? Plus or minus 1 and? Plus or minus 2. Great. What are the factors of our lead coefficient? Plus or minus 1. Okay, so basically just the factors of the 2 part are the ones we need to worry about. Now pick one and test it. I'm going to pick the 1. Oh, actually, just kidding. I'm going to pick the negative 1. And then we're going to use synthetic division. Remember, if we get a remainder of 0, then negative 1 is one of our zeros. It's one of our solutions. It's one of our roots, part of our answer. I think you guys are getting pretty good at this process. Is that accurate? Okay, good. All right, and you can see that -1 does work. -1 is one of our answers. So now we're looking for the rest of them. We should have 3 more that we're going to find. Now, just like yesterday, we can use this polynomial. Remember, this is synthetic division, so it's basically just dividing out this solution. We can find the rest of our solutions from here. That gives us this polynomial. Remember, these are your remainders. You shouldn't have any remainders. And then this is your constant, your x term, your x squared term, your x to the 3rd term, and so on. So that gives us this. Now, if you look through here, you can go through and list the possible roots just like we did with the original problem. However, what are the possible roots here? They're just the factors of -2. What are the factors of -2? Plus or minus 1, plus or minus 2. It's the exact same numbers that we're working with. So now we'll just do the process again. This time I'm going to start with the number 2. You can actually go right from this setup. Just forget that the 0 was there, because you're still using the 1 first, then the -2, then the 1, then the -2 again. So now I'm just going to do synthetic division again, forgetting about this 1, because that was my remainder. Same old process. Remember, if we get a remainder of 0, then 2 is one of our roots as well. And you see that does happen. Now we have a remainder of 0. So now I've found 2 of my roots, -1 and 2. Again, we'll use the polynomial we have left over to find the rest of our roots. What is the polynomial left over? What is this? Remember, this is your remainder. So kind of work backwards. What term would this 1 give us? X squared plus 1. You don't have any x's because of that 0, so we just have x squared plus 1, and we want to find the zeros for this polynomial. So you're basically just narrowing it down until you have a total of 4 solutions. How would we solve something like that? It's not a difference of 2 squares because we have a plus sign. But I heard a couple people say you can subtract 1 from both sides. And then you can take the square root. What's the square root of -1? Plus or minus 1i. Good. That's exactly what we saw in the video. Remember, complex solutions or imaginary solutions, they come in pairs. If I is a solution, so is -i. And then we have the solutions we found through our synthetic division steps. Is that 4 solutions? Yeah, you have the positive I, you have the negative I, you have the -1, you have the positive 2. That's 4 solutions, so you're done. So you can see it's a very similar process that we did yesterday. They're just kind of getting a little harder. So this might help you with your homework questions too from yesterday. Any questions though as we're looking at this? All right, here's our next one. So let's list all the possibilities. What are they? 12 and 1, 2 and 6, and 3 and 4. Good. And our lead coefficient's 1, so that's not really going to change anything when you do that division step. So those are all of our possibilities. All right, I'm going to go ahead and set up synthetic division to see which one works. I'm going to start with testing out the 1. So my top line is going to be 1, -8, 19, -12, and then just go through the process. So we're going to drop the 1, multiply by 1, -7, multiply by 1, +12, multiply by 1, and I get a remainder of 0. Remainders of 0 are good news. That means you found a solution. 1 is one of our answers. Now, use your leftovers to write another polynomial and continue the process. Do we need to do synthetic division here, or do we know an easier way? Yeah, you can just factor this. Don't make it harder than it is. If you want to set up the 1, -7, 12, figure out the possible roots, plug it in, test it out, that's fine. That process will always work, but a lot of times there's a much easier way. There's a much easier way here. Multiply, add. Anyone know what the combination is? What?
X minus 4, X minus 3.
Good. Lots of good guesses, but -3 and -4 multiply to +12, they add to -7. So that gives us a solution of 3, a solution of 4, and we found the solution of 1 earlier. Double check you have 3 solutions. You have a 3rd degree polynomial, so we're done. All right, let's list the potential zeros. What are they? 1, 2, 5, 10, all with plus or minuses. Good. Our lead coefficient's 1, so it's not going to change any of them. We don't really have those fraction type possibilities. Just the factors of -10 are going to be our possibilities here. Let's do some synthetic division. I'm going to just go with the 2. Kind of ruining all the fun today. Now on your own, you probably would have done 1, then -1, then the 2. But let's just see how this one works out. Here's 1, -2, 5, -10. Drop the 1, multiply by 2. You get a 0. You get a 0. You get a 10. And our remainder, you probably saw this coming, is a 0. Good. So 2 is one of our roots. How many more are we looking for? 2 more. We should have 3 total. We just found one of them. What? I heard somebody say it. Somebody say something. What's the polynomial we have now? What are we working with? X squared plus 5. Good. There's no x term because we have a 0 in the x column. How would I solve something like this? Subtract 5. Then you're going to take the square root. The square root of -5 is plus or minus I square root 5. Our other solution is 2. We already found it. Now, this is exactly what we were talking about in the video. Anytime you have an imaginary solution, you should have both of them, the positive option and the negative option. Okay, so put the plus or minus in front. Remember, imaginary solutions come in pairs, come in conjugates. What are your questions? All right, now usually when we're doing the whole like PQ thing, we're talking about the constant is the P part. Do we have a constant here? No, but what do you notice about each term? It has an x, so let's factor out the x first. Now do we have a constant? Yes, okay, so now we're talking about the factors of -12. What are the factors of -12? 1, 2, 3, 4, 6, 12. Good. Again, I'll ruin a surprise. I'm going to try 2. So when you're setting this up, we're going to kind of forget about this x for a second. Right now, we're just working with what's in parentheses. What solution is an x going to give us? Do you guys remember? Not 1. It'll give us 0. So we're going to remember this at the end, that 0 is going to be a solution. For the rest of the time, we're just going to work with what we have in parentheses to find the 3 roots that this portion would give us, and then remember 0 is going to be from this x right here. All right, so 1, 3, -4, and -12. You do not need to worry about the 0 or the x in front. That's just going to give us 0 at the end. All right, do your synthetic division step. You can probably guess your remainder will be 0, or why else would I have picked the 2? There we go. So I have 0 as a solution. I have 2 as a solution. What else? What from here? Yes! Yeah! This is just a trinomial now. Do multiply, add. What is it? Very good. 3 and 2. That gives us -3 as a solution. It gives us -2 as a solution. It gives us 2 as a solution. And then this x gives us 0 as a solution. The 2, because I did synthetic division and it gave me a remainder of 0. So if this was on your homework, you probably would have tested 1 first. It wouldn't have worked. Maybe -1, then gone to the 2. So you might have a little more work in here. I kind of ruined the surprise. All right, so I keep saying solutions. Really, I should call them zeros or roots. It would only be a solution if it was set equal to 0. So I'm kind of using the wrong terminology. Now, remember what we did right before break. Zeros or roots are the places that your graph crosses the x-axis. So if I took this a step further and said, now I want you to graph this, you would have your graph crossing at the 0, crossing at the -2, crossing at the -3, and crossing at the +2. And then you'd have to do an XY chart to kind of predict what's happening in between there. Okay? Remembering what we know about end behavior, though, it's a positive lead coefficient, so I know that it's going to act kind of like a parabola with a positive a value, so it'll look something like that. But just kind of keep that in mind. That's kind of tying it back to what we did before break. I don't want you to forget about that stuff. But do you guys have any questions on this? Tomorrow we're going to look at graphs again, so I'm just kind of trying to keep your brain thinking that way. But for today, we're just finding the zeros. Any questions? All right, this is a different type of problem, but you will see it tonight in your homework. It says write a polynomial function of the least degree that has real coefficients, the given zeros, and a lead coefficient of 1. So they're basically saying, well, these are your answers. What was the problem? Well, let's kind of work backwards. How would you get an answer of 2? What binomial would you have to have? X minus 2. What binomial would give you a solution of -1? X plus 1. What binomial would give you a solution of +5? That's the easiest way to do it. You can make it a lot more complicated, but I would go the easy route. Just think of the easiest factor or the easiest binomial that would give you that solution. Now what? distribute lots of times. So that's going to give us an x squared. It's going to give us a plus x minus 2x minus 2. Let's clean that up and distribute again. So that's going to give us x to the third minus 5x squared minus x squared plus 5x minus 2x plus 10.
Why behind that 5x squared, that negative, that next x is a negative?
What's your question behind this one? Why is this a negative?
Yes.
So I distributed the x squared, then I'm distributing this negative x. So negative x times positive x is negative x squared, and then negative x times negative 5 is plus 5x. Plus 3x plus 10. So this is our function. F of x equals all that. Now, an easy way to double check would be to get your graphing calculator out or go to a computer with the internet and go to an online graphing calculator. Type this in and see if this is where it crosses the x-axis. If it is, this is the right function. If it's not, you need to start over. Any questions? So what would give us 4 as a 0? What factor would give us a 4 as a 0? X minus 4. Good. What factor would give us negative 3 as a 0? X plus 3. Good. What factor would give us a positive 6 as a 0? X minus 6. Great. The rest is just simplifying. Double distribute here. So you get an x squared plus 3x minus 4x minus 12 times x minus 6. Distribute again. So now you have an x to the third minus 6x squared minus x squared plus 6x minus 12 plus 72. So my function is going to be what you get when you combine your like terms here. Oh, I dropped an x. Sorry, that 12 should have been x with it. Minus 6x plus 72. What are your questions on this? Here's your homework for tonight, 15 to 39. Just the odds, like always. Make sure you're checking your work as you're going through these. Bring questions. We'll have time to either do on Thursday or Friday of this week. Remember, we have a quiz early next week, so make sure you're keeping up. Any questions?